Here we go. We have a question. Find elements in a contaminated binary tree. So we have a binary tree. The root node is of 0, and for any node, if value of a node is x and its left side is present, so its left value will be 2 cross 2 cross x plus 1. And if the value of a node is x and its right side is present, so the right side value will be 2 cross x plus 2. So this thing reminds me of priority queue when we make priority queue in an array. So this particular properties applies there, but this question is not related to priority queue. This is a binary tree question. And the next thing is, now the binary tree is contaminated, means all the values change to -1, and we need to implement two things. Find elements. This is a constructor. We need to initialize the object with contaminated binary tree and recovers it. Then we need to find if any target is present in tree or node. So we have this. So it's numbering. The root node numbering is 0. Its left is not present. Its right numbering is 2. So this is the real binary tree. The numbering will look like this. Next we need to find whether 1 is there. No, the answer is false. Is it 2 there? Yes, so the answer is true. Then in this, the root node labeling is 0, its left labeling is 1, its right labeling is 2. Then its left labeling is 2 cross x plus 1, 2 cross x plus 2 is its right labeling. So we have 3 here, we have 4 here. So then we have built it. Then we need to find 1. Is 1 there? Yes, 1 is there. As you can see, this is the correct binary tree. 1 is there, 3 is there, and 5 is not there. So so this is false. And we have one more example. Okay, so we have this binary tree. Root is 0, left is not there, so right is 2 cross x plus 1. 2 cross x plus 2 is its right. So right, then its left will be 2 cross x plus 1. 2 cross x plus 1 is its left. Then we need to find 2. 2 is there, answer is true. 3 is not there, false. 4 is not there in the tree, false. 5 is not there, 5 is there, so it's the answer is true. Let's build the approach. So let's suppose we have a binary tree. So this is contaminated. So we have this binary tree. Then we need to find whether some values are there or not. So let's suppose we have these values, and we need to find whether that value is true or not. So we will just need to find whether what are the numbering of a particular node, and we need to store the numbering. Then if a function asks whether a particular target is there, we will just tell in order of one space. How we gonna store it and tell whether a particular value is there? So we're gonna use set data structure. Then how do we find the labeling? We know it is 0, so we have a node. Then we insert its numbering. Then we go to its left. So its numbering is 2 cross x plus 1, 2 cross x plus 1, 2 cross x plus 2. Okay, so we have 1. We are onto this node, so its labeling is 1. So let me okay, so its labeling is 1, so we're gonna store 1. Then we again go to its left side. So its labeling is 2 cross x plus 1, it is 3, so we're gonna store 3. Then we go to its left side, it is null, so we're gonna just return back and go to its right. 2 cross x plus 2, 6, 7, 8, so it is 8, we're gonna store 8. So then its left is null, its right is null, so we will return back. Then we gonna return back on this side. Then we move to this side. So 2 cross x plus 2, 2 cross x, which is so 4. This is 4, so we're gonna store 4. Then left it is null. Okay, So then move on to this side. So it is 10. So we're gonna store 10. Then we move back and go on this side. So 10. Then move on to this side. So it is 2. Store 2. It's left 2 cross x plus 1. So 4 plus 1 5. So we're gonna store 5. Its left is null. It's right 2 cross x plus 2, which is 12. And its left is null, return back. Right is null, return back. Its right is null, so return back. So we have store every number. Then if a function asks whether 1 is there, so 1 there in our set, so it will tell me in order of 1 space, order of 1 time. So 1 is there, then 2 is not there, 4 there, 9 not there, 10 yes, 12 yes, 24 no. So that's how this approach will work. So it's a pretty straightforward question. Now let's build the approach. Let's code this. So we need to complete this and this. This is the constructor. So inside the constructor we gonna implement something. So we only need set. So first implement this set. Then we have a solve function. In the solve function we have a node and its number. What its number? So we have a solve function. This is a recursive DFS tree node and its number. Number is, let's say, x. So first we gonna store its number. Before storing, let me check. If this is null, just return back. Then move on to left side. So left side will be 2 cross x plus 1. Then move on to right side, which is right, then 2 cross x plus 2. Then we need to check whether it is there in our set. So set dot contains target. If it contains, it will tell me yes, otherwise false. So let's run this and see if there is any error. No. Let's submit it and I hope it will work. Then let's talk about time and space complexity. We have submitted this code. What are the what's the time complexity? So we have a function find. So what's the function name? Find elements. So we have find elements constructor. So it calls solve function, which will iterate in each and every node. So it will take order of n time, and space is also order of n. Then we have a find function. So it will do the work in order of 1 space and order of 1 time. So the time with space complexity is order of n and order of n. So I hope you have learned something new. Give this video a thumbs up, subscribe to this channel. Thank you all for watching this video.